Hey everybody, Mr. Tannen here. Just want to make a quick video for our asynchronous day. You can put this on double speed right now if you like. Just to recap, we talked about yesterday SO, CA, TOA, sine, opposite hypotenuse, cosine adjacent over hypotenuse, tangent, opposite over adjacent. And actually, I believe uh, somebody in my last period class had the suggestion. Well, this was sort of not intuitive for me, but the reciprocal of sine is not secant. The reciprocal of sine is cosecant, and the reciprocal of cosine is just secant. But somebody said, well, the way I remember is that each pair, a pair and its reciprocal, has one that starts with C. So you notice the reciprocal of sine is cosecant. Well, cosine starts with C, so its reciprocal is just secant. And then tangent also, its reciprocal is cotangent. So that's one way to think about it, that every pair of uh, the trigonometric ratio and its reciprocal has at least one that starts with C. Interesting. Another thing, just to remind everybody, is when you're using your calculator, just ensure that it's set in degrees. We'll talk about radians actually very soon on Thursday, but in this case, we've been just talking about degrees. So if I go down, you'll see I have the option to have my calculator in radians or degrees. So if I do sine of 30, because it's in degrees, that should tell me 1/2, which we're starting to see is one of the ratios that comes up a bit. Okay, so let me close that out here. So I wanted to look at these problems, and again, you could put it on double speed if you haven't already, or just continue watching at this speed if you like. But sometimes if we have a situation, we're going to need to determine how to approach a problem strategically. And sometimes you'll have some different ability to choose um, what you'd like to do. But here they're telling us you're hiking near a canyon. When standing at A, you measure an angle of 90 degrees between B and C. So you can see here, it's a little hard to, but this is actually showing a 90-degree angle right there. So what that means is, could we then find the distance between A and C if we know that A to B is 2? And so, well, let's think about it here. So we have this angle. So that's sort of what we're going to think about with regard to these ratios. Well, we have the adjacent side and we're trying to find the opposite side because this over here is the hypotenuse. Ooh, that's kind of hard to see that green, but so if we're trying to find the opposite and we have the adjacent as 2 miles, well, TOA opposite over adjacent, which is why they set up this equation. The tan of 76 degrees equals the opposite over the adjacent, x over 2. Multiply by 2, calculate, it's approximately 8 miles. Not too bad. Here they're talking about if you look at a point directly above you, such as the top of a building, the angle of your line sight makes with a line parallel to the ground is something called an angle of elevation. Whereas if you're looking down at something, if you the angle between a line parallel to the ground and your line of sight would be the angle of depression. So if I'm to draw this here would be the angle of depression. This right here would be the angle of elevation because we are able to use that. I'm not sure if anybody here has ever been parasailing, but this is like when I think you're on a parachute and a boat is pulling you along. That's called parasailing. Interesting. Looks like a fun time. So a parasailer is attached to a boat with a rope of 72 feet. and the angle of elevation. So if this is my parasailer, I'm going to reconstruct this over here. So that would be 90. Here's your person on the parasail. And then here's the boat pulling it along with its little motor. What does the front of a boat look like? Something like that. Here's the pilot. The captain, I guess would be the right word. So they're telling you that this angle of elevation is 28 degrees, as you can see from the diagram. The rope is 72 feet long. So how can we determine how high the parasailer is above the boat, H? Okay, well, I have this angle, so let's think what these sides are with regard to that. Well, that's the opposite, right? It's the one that is not the leg making up nor the hypotenuse. So we have the opposite. We're trying to find H, and we know the hypotenuse. So which of our trigonometric ratios uses the opposite and the hypotenuse? Sine. So, Katoa, the opposite over the hypotenuse. So if I go back here, what I could do is set this up as so, well, the sine of the angle has to be the opposite over the hypotenuse. Multiply both sides by 72 and we can find the height. So these don't necessarily become too bad because these trigonometric ratios tell us quite a lot and can help us solve in these situations when we are encountering a scenario that can be modeled by a right triangle. Hope this video was interesting. Have a great day, everybody.